We are online.
Okay, so welcome everybody. I'm very happy that our cycles of seminar about AI society, we are back. Okay, so although we are of course in a difficult situation, we cannot continue our project as we would have liked in person, but still we have this opportunity to meet, let's say, virtually meet scientists all around the world. And I'm very glad that today we have with us Professor Edmond Awad. He is a lecturer in the Department of Economics and Institute for Data Science and Artificial Intelligence of the University of Exeter. And also he is our associate research scientist at the Max Planck Institute for Human Development, and founding of the editorial board member of the AI and Ethics Journal. So I'm very glad that today he is going to speak about a very interesting and important project that he developed when he was at the MIT Media Lab, titled The Moral Machine. So the Moral Machine, as we will see, is a website that gathers human decision on moral dilemmas, in particular faced by driverless cars, that you know is a very important topic, and autonomous driving is one of the main challenge that we want to tackle as a society in the futures. And the website has been visited by over 4 million of users, and so as we will see, contributed to collect the judgment on 70 million dilemma. So it's a very, let's say, practical way to tackle ethical dilemmas that in modern artificial intelligence we cannot avoid. And so I'm very glad that today we have the opportunity together to better understand such a project and to discuss with Edmond. Thank you very much.
Should I share?
Yeah, you can share, Edmond.
Yeah, thank you, Samir, for the nice introduction, and thank you for the organizers for inviting me to this interesting seminar to be part of it. As Samir said, I'm going to be talking first about the moral machine experiment, but then I will also talk about a couple of other follow-up projects that were inspired or related to it. Okay. As you all know, driverless cars are already being tested on the roads, and in some time in the near future, they may become a reality, which could be a good thing, because many experts say that these cars will be reducing 90% of the current car crashes. Now, whether this number is accurate or if it's like 50% or 40%, it seems like they're going to make a much better progress over the human drivers. Now, let's suppose that they will actually reduce 90% of those crashes. The remaining 10% may still involve cases of cars resolving moral trade-offs. Now, let's see a very stylized or abstract version of these moral trade-offs. Is inspired by something called the Trolley Problem, which is a philosophical conundrum. Here's the autonomous vehicles version. You have here an automated vehicle. You have an automated vehicle headed on the road, and then 10 pedestrians jump in front of it. Brake fails. The car is now about to kill those 10 pedestrians, and the only way out is if it swerves into a passerby, sacrificing them to save the 10 pedestrians. Should the car do that or not? In another version of this dilemma, the car will swerve into a barrier, killing its own passenger in order to save the 10 pedestrians. So should the driverless car, if it was put in a situation to sacrifice its own passenger in order to save 10 pedestrians? In this question and other similar questions were posed by my collaborators, and they found that and they published these studies in Science in 2016. They found that most people actually approve of sacrificing the that the car should sacrifice the passenger in order to save 10 pedestrians. But there was a catch. When they asked them if they're willing to buy these kind of cars that would sacrifice their own passengers, they thought that they said they would not, even though that they thought that everyone else should do, which kind of poses a case of a social dilemma where everybody wants everyone else to do the right thing, but they don't want to do the right thing themselves. Now, let's talk a little bit about this dilemma. Many of you might have started thinking that, it's possibly this dilemma is very rare and maybe will never even happen. So why is it really important to think about it now, right? And many of you who drive and have been driving for a long time have never faced these situations where they have to either kill one person or have to sacrifice themselves to save 10 pedestrians, which is true, right? While we're driving, we probably don't face these kind of scenarios, but that doesn't mean that we don't face moral trade-offs. In fact, the moment you go and buy a car, any regular car, you're actually faced with a decision. When you buy this car, your decision has moral consequences. You might decide to buy an SUV or a sedan, for example, and each one of these, like one of them will probably have a better protection for you and your family at the cost of other people on the streets, or have a better environmental influence, or worse. After you buy this car and while you're driving yourself on the road, you're also, while driving, you're also shifting risk on the road in different ways. Let's take just for this example. Imagine that you are the person who driving the car in the middle lane here. Now, while you're staying within your own lane, let's say you have a big truck on your right and a cyclist on your left. You may, subconsciously or like unconsciously drive closer to the cyclist because you're a little bit worried about the truck. In this case, you're introducing more risk to the cyclist on your left. You may also instead, like, you're very conscious about the cyclist, so you drive closer to the truck, in which case you are increasing risk to yourself. Now, each person makes their own decisions, and in many cases, you're making these decisions without really realizing or without really thinking about what your moral decision is. But now think of a driverless car that have this software in it that have all of these decisions implemented ahead of time. It does not get affected by stress or the spur of the moment. It also, the same software that makes the same kind of decisions is implemented in hundreds of thousands of cars. Right. So now every kind of small shift in your lateral shift in your decision will, in aggregate, might materialize into actual casualties. So now let's say in all of those cases, in this one instance, you decide you're going to go, let's say, closer to, let's say, for example, to the cyclist. Sorry, you go closer to the truck. After a million of those instances where you have been, let's say, if all the cars were just taking the same decisions using the same software, are just going closer to the truck. In this case, you might end up, like, after all of these instances, with 5 passenger fatalities. Now, imagine that we have another company that uses another software which does the opposite, just goes closer to the cyclist. Then maybe after all of these instances, we will end up with 1 cyclist fatality. So in aggregate, we will end up with the same dilemma. It's just this is the statistical version of this dilemma. So in fact, these kind of when we talk about these situations, let's keep in mind that the discussion is basically about who is being disadvantaged on the aggregate level by the programming of these driverless cars. It could be that the way the driverless cars are making their decisions are not necessarily taking this into consideration. But as a byproduct, they are actually disadvantaging some road users. Now, in fact, Google have made some kind of like a calculations as well in their way of calculating the risk. They do like a risk penalty from probability and risk magnitude for all sorts of events. So this is already it's already available there, the way that the risk is calculated. Because we think that the public, engagement is an important part of the puzzle, especially with the emotional salience of accidents that are done by driverless cars. And so because of that, we wanted to basically try to kind of have increase the public engagement and bring this discussion to the public eye by building this website, which we call Moral Machine. And Moral Machine is basically a website that generates random moral dilemmas faced by driverless cars and asks you what you think the car should do in these dilemmas. As we see here, like this is one example. For example, the car is headed on the road, and now this is a driverless car, and you have 4 pedestrians jump in front of the car, brake fail, as in every story, and the car will either continue to kill those 4 pedestrians, which we see here on the left side. We have this skull on their head, which means that in these scenarios, these 4 will die, or it could swerve to hit the barrier and sacrifice its own passenger, which is a one female athlete. Note here also that the 4 pedestrians are crossing on the do not cross signal, so they are all jaywalking, including the dog. So when a user comes to the website, they see 13 of these 13 variations of these scenarios. They click through, they click the one that they think the car should do. And at the end, just to make this exercise more kind of exciting or more interesting, we provide them with a summary of their results. We tell them, like, this is how your answers were in those 13 scenarios. For example, like when it comes to sparing more lives, this is how much you care about sparing more lives or protecting passengers, and this is how you compare to other people. When we designed this, so now it's important to say that this was also created as a large or massive psychology study to collect data. So collecting data about different scenarios, and it was designed as an experiment. And in order to increase the validity of our results, we basically created different types of characters. Here you can see basically a family picture of all of those characters. We had like males, females with different like athletes, doctors, executives. We have a dog and cat as well. And each scenario, the way we draw it on the screen, is basically composed of 4 main components. We can see that the first component here is whether the car continues straight or swerve. And this is related to omission commission. The second component is about the casualties, the potential casualties themselves, who could be either pedestrians or passengers. So like, what's their relationship to the AV? And the third part is, if they are pedestrians, they could be crossing legally or illegally, or sometimes this factor is, they could be crossing neither legally nor illegally. We don't just put traffic light at all. And also the types of, like, some kind of demographic description of those characters. In this case, we have elderly on one side and we have young on the other side. And to be more clear about those factors, so here we have basically had like 9 factors in total. As I said, the interventionism, cars stay or swerve, the relation to AV, the legality, whether they're crossing legally or illegally, and then the other demographics. Are they males? Put males versus females, the gender, the age, fitness level, social status, species, and number of characters. And then we vary those attributes and at the top of each other, which results in a huge number of possible cases, which also requires like a huge number of people or participants to answer each of those cases. And we translated the website to 9 other languages. This is once we started realizing that the website is actually getting a lot of people. It was a painful task actually to translate a website to 9 other languages. But eventually we did it, and it was worth it. We had 4 million users within the first 18 months. And those users answered the 40 million of the dilemmas also within the first 18 months. I think now we've crossed the 70 million dilemmas, which are the dilemmas that you just saw. And we had an optional demographic survey at the end, which we had like 500,000 people who filled that survey. And people came from around the world, from different places in the world. In fact, we almost had at least one input from 233 countries and territories. Here you can see the distribution of their locations. And just for comparison here with the map of where there is light or electricity. Now, obviously, here you can see that while there is a good coverage of areas where there is light, obviously there are places where they don't have electricity or internet, which obviously would not be able to reach our website. And this is something to speak about the samples of our data as well, which is something we could talk about later. So what did we find? I'm not going to talk now about the main results of this website. First of all, to explain what we find, I'll just explain this figure here. So on the right here, you would see we have sparing humans. We take all the cases where we had humans, and we see how often people spare those humans, right? So that would call this probability of sparing humans, right? And then we take all the cases where we had pets, and we see how often people spare those pets, and we call that probability of sparing pets. And then we subtract these two numbers, and that would be our x-axis. So here, delta P is basically the probability of sparing humans minus probability of sparing pets. Since we see it's going to the positive, it means people spare humans much more than they spare pets, and it's close to 0.6. Similarly, we can do the same thing for more versus fewer characters. In this case, the more each time you include one more characters, this is how much it increases the probability of sparing those group of characters. So if you add one characters, it added so much. If you add 2, 3, and if you add 4 more characters, that's even that's the difference is more than even the difference between humans and pets. And then you can do the same thing for all the other attributes, and we can also compare all those attributes. So here we can see that at the bottom 3 rows, we have like especially as we talked about humans over pets, and then sparing more lives over fewer lives. But then the third one is sparing the young over the elderly. So we can see like that, especially these 3 factors were the strongest among the 9 different factors. Obviously, we also have sparing the lawful over the unlawful, and then sparing the higher status over the lower status. I'm talking here from the bottom. Now, sparing humans over pets and sparing more lives over fewer lives are both quite like it's usually things that many people agree with. Sparing the young over the elderly is an interesting case because in some situations, people find it acceptable. In other cases, it's not. I'm talking about the experts now. So it was kind of, we were kind of curious about sparing the young over the elderly. So we could do this actually at the level of each character. So now we can do the same calculation, but now we're going to take adult male and adult female, which are here in the middle. And we also calculate the probability of people sparing them. And then we compare that with we subtract this number from the probability of sparing every other character, right? So now for first, let's say we take the baby stroller, and we see that people spare the baby stroller much more than they do, or let's say like at least something less than 0.2 difference of probability from sparing the adults. When we do that to all the other characters, we can also compare them in the same way. Now, if we look at the top 4 characters, we can see we have baby stroller, we have a girl, a boy, and a pregnant woman. And here we can see that all the top 4 characters are related to young characters, basically. So this is to say that also the same thing, if you look at the bottom, aside from the dog and the cat and the criminal that comes just weirdly in the middle between them, comes the elderly man and woman. So in a way, it seems like the preference to spare young over elderly is something that is not driven by just one or two characters. It's just something that is kind of quite driven by all the types of characters. I'm going to talk a little bit about this in a minute. Now, because we had people coming from all around the world, we decided that we basically can actually calculate those 9 numbers for each of these countries, right? But here, provided we had enough data from each country. So for this analysis, we had to only consider countries from which we had at least 100 participants. And let's say now we calculate these 9 numbers for each country. So each country could be represented by this vector of 9 dimensions, and we can calculate, let's say using a Euclidean distance or any kind of distance, you can calculate distance between every pair of countries. Then we can actually do something more. We could use hierarchical clustering to cluster countries, and hierarchical clustering actually not only cluster countries but also give them they cluster them in hierarchy. Which could be visualized using this dendrogram that I show in this picture. I'm going to talk more details now, but before, just notice how the color of the branches, we have 3 colors of branches, and here each branch, basically the countries that are related to each branch color are closest among themselves than they are to the countries of the other branch. The country names are colored based on some classification that was put by these 2 scholars, Engelhard Welzel, who created their own cluster of countries in the past, which says that countries are classified into one of those 10 possible classifications: South Asia, Protestant, Orthodox. So we use this color here for just visual inspection. So we found, as I said, 3 clusters. The first cluster, and I'm here rotating the cluster, we call it Western cluster. It had many Western countries. We will see in it using the colors. We see that there are many English-speaking countries, many Protestant, a majority Protestant, majority Catholic, and Orthodox majority kind of countries. The second cluster, we called it Eastern cluster. It has also countries, many countries that are Islamic or Confucian or South Asian countries. And the third cluster, it's basically a combination of 2 subclusters. One of them has like a clearly almost entirely Latin American countries, and the second one is curiously former French colonies. Which you can see, including France itself. What we could do next is to see how each of these 3 clusters differ from the others in terms of their preferences. So here I'm showing you the Western cluster, and these are z-scores. So z equals 0 means the average. And the important note is that when we calculate those numbers, the 9 numbers, if you remember in my initial figure, we had things on the right and things on the left, and the preference was always for things on the right. So for example, people spare the young over the elderly. That's something that we found almost in every country. So in terms of direction, we see some sort of universality. But when it comes to how strong the preference for young over elderly is something that varied among countries. So here we see that the Western has a lot of on the z equals 0 because most countries were actually from the Western cluster, so they kind of like in a way closer to the average. But interestingly now, if we look at the Eastern cluster, we see that that sparing the younger was, while it's still the preference over the elderly, it is in the Eastern cluster less pronounced in the Eastern cluster than in the other 2 clusters, which is kind of inconsistent with other research about Eastern countries and their respect for the elderly, like a special respect for the elderly. You could also see that the Southern cluster, for example, they have a special strength of sparing the females over the males, and this is something that is highly driven by the French subclusters, which is kind of something that is also we don't have a special explanation for, but it seems like France especially differs from the other European countries in their strength of sparing females. But also sparing females over males is something that we also found universally in terms of direction. It's just in European countries, the difference was probably smaller. Next, what we can do is actually try to see what, let's say, cultural factors that could predict those differences between countries. And one factor that is usually very well studied is individualism versus collectivism. Individualist societies or countries are countries where people have high trust in their institutions, where people focus on the individual, on values that are related to the individuals, like reputation of the individual, their honesty, while a collectivist society are places where people have, they don't trust centralized institutions. People seek their extended families for protection, and they see themselves as part of their extended family or tribe. The family ties are usually stronger in those societies. One thing we find here is that there is a correlation between how strongly individualist the country and sparing more lives, which is kind of also makes sense given that individual society are kind of like egalitarian. So more lives will always be more important than fewer lives, unlike in the collective societies where other factors could play in. Another factor that we also find predictive of something in our data is rule of law, which is basically also an index for how strongly respected the law in each country. And we find the correlation with sparing the lawful. Again, sparing the lawful over the unlawful. And when I say lawful and unlawful, I'm talking about whether people are crossing on like a jaywalking versus they are crossing on the green or walk signal. So we see here that in almost most countries, people do have a preference to spare the lawful over the unlawful, but this difference is stronger in countries where rule of law is where they have a high rule of law, or like law is highly respected. Okay, so now that I talked about the results, I'm just going to explain what are some implications, or what do we learn from these results. It's important to note that everything that I've talked about so far is, let's say, when we talk about ethics, usually there is a distinction between normative ethics and descriptive ethics. Normative ethics is what we should do, right? It's the right thing, and it's something that usually experts are usually better informed about. Descriptive ethics is what most people usually do, or what most people think they should do, or what our cultures or norms sometimes tell us to do. It's not necessarily the right thing to do. So this is an important distinction between normative and descriptive ethics. And what we were doing here was basically considered under descriptive ethics. Now, what about normative ethics, right? Because that is the important part. But it's also it's important to say that both descriptive ethics and normative ethics basically inform policy and regulations in different ways, right? So what is the normative ethics about these things, right? So Germany is basically the first country that started thinking about this. And in 2016, they formed a committee of experts that came from different domains, from law and ethics, engineering. They also had a bishop. And this committee of experts sat together and they came up with a set of guidelines. What I'm going to do now is just to show how what we found, how much different or how it overlaps with what they came up with. As I said, the strongest thing we found is that humans over pets. This is something that is not in disagreement with what they said, which is that we should be accepting damage to animals if that means we can avoid human injury or human risk. The second factor is also not in disagreement. They also had some kind of guidelines where it said the general programming to reduce the number of, so we said that more lives over fewer lives, or like most people said that. And that is not in disagreement with the committee, who said, it's justifiable to program to reduce the number of person injuries. But the committee also, as some of you may realize, that this is a utilitarian viewpoint. Some of the committee members were more deontologists, so they were not completely happy with leaving this sentence around. So there was another sentence as well in these guidelines that says that also we should not be putting lives against each other. So in a way, they included both statements. So we cannot say that the committee have made us a determined or specific stand on this, but we can say that it's not in disagreement or with what they said. Young over elderly, this is the third strong preference that we found, and this is in clear disagreement with what the committee said, that say that there should not be any distinction based on personal features. Now, again, as I said, young over elderly is something quite controversial even among experts, and in some domains, like in the medical domains, it is allowed that to give preference to younger patients in some cases over older patients. Lawful versus unlawful. That is also something that was not completely in disagreement with the committee, but what they also wrote was something more abstract. So they said that the parties involved in generation of risk should not sacrifice non-involved parties. And this could be understood in many different ways. But in this case, we can think about it as, let's say if the whole dilemma came about because somebody was jaywalking, then this basically says, well, you should not make the people who were crossing legally pay the price. Now, the committee also do not say you should punish those who are jaywalking, because that also seems like a disproportionately harsh punishment for just jaywalking. And they do say that, that does not mean that you should sacrifice the others. But again, the committee is not very clear about it, and this is a byproduct also of putting a group of experts together who disagrees about those cases as well, which is also tell us something about that normative ethics. There are disagreement among the experts themselves, so it is not completely decided in many cases. And I think in those cases, this is where the public opinion could be important, where they could play a role. I'm just going to talk about the higher status over lower status, which is clearly in disagreement with the committee. So as we see here, there are some cases where there is agreement. There are cases where there is like a partial agreement, and cases where there is like a clear disagreement. It is important to know now, what do we do in this case, right? And I think this is something that is left for the policymakers, who may completely ignore the public's opinion, or they may actually be convinced by it, or they may actually only use it for breaking ties. Sometimes they're not going to follow it, but it is important to, for example, they may not give any preference for young over elderly, let's say, but at the same time, they prepare to give explanation for why that decision was given. So it is important to know what the public think in this case. The second implication is about the cross-country differences. As we said here, we had different countries had some kind of variations in their answers. I'm just going to talk about one example where how this could come in play. Suppose we have one company and they have some level of safety for their cars. And suppose that this company have figured out a new update, software update, that will basically provide more safety. Okay, so it's less harm. But let's just assume now, for the sake of this example, that this less harm is conditional on the fact that everybody is crossing legally, right? So this new update will provide us in a safer system, but only conditional on the fact that everybody is crossing legally. But suppose that those who are crossing illegally, in fact, are more harmed in the new system, right? So now we have a new update where some people are less harmed, others are more harmed. So in that case, what should the does that mean that we can roll in the update? Does that mean it's okay to do that or not? It could be that people in countries where rule of law is stronger, they would find this update morally imperative to have in place, while in other places they might find it outrageous or unacceptable. I'm going to move now to another part of research that is not related to the moral machine, but it's still related to driverless cars. So now I'm not, as we see, we talked about fully automated vehicles, the vehicles that are driving by themselves. But before reaching that stage, and even some companies are actually aiming for driverless cars that are not fully automated, where cases where the driving task is shared by both the human and the car. One example, so in those cases where we have humans and machines are sharing control, how is the blame when something wrong happens? How do people attribute blame? So we're going to talk about these two main examples. I'm here using the British car style, like a right driver is on the right. So if you look at the autopilot mode, which is Tesla is working on, which says that it's not completely automated. The car is driving itself most of the time. So here, this robot is driving, as in the British style, most of the time. But there is a human driver on standby, and this human should override or take over if they think it's necessary. So they have a duty to override if they think it's important. On the other hand, there is another model called Guardian by Toyota and some other companies, where it's basically the human. It's a regular car. Human is driving the car, but it also have a software that could override if it thinks that the human is messing up or is about to do something wrong. So here we have it. Both car models both have two drivers, one that is in control and one on standby, but with the roles of human and machines are reversed. Okay. And here, just to connect this with context, as you all probably know, in March 2018, I think, there was this crash in Arizona, Tempe, Arizona, where the car basically was more like the Tesla autopilot. It wasn't Tesla, it was Uber, but it was the autopilot model. And there was a pedestrian that was killed. Some of you probably saw the short video that was also shown, where the person in the car showed the person in the car was like looking down, and the car didn't see the person. Before that, there was also another crash involving Tesla car, which ended up in killing the person inside the car who was just driving Tesla. And in that case, there was a white truck that neither the car nor the person could see. Other people talked about different story, that the car decided to just do some kind of maneuver. Anyway, this ended up with killing the person in the car. In both of these cases, there was some sort of like a media, obviously there was a huge media coverage for these two crashes, but there was also kind of interestingly some kind of blame put on the human in the car. There was, after the first crash happened, there was some kind of article saying that the person in the car was watching Harry Potter, and this was based on a claim by the person in the white truck who said that they heard the Harry Potter theme around the crash time, which later articles said that there was no evidence for this. And then also with the more recent Uber crash, there were some articles saying that the person in the car was watching something on Hulu when the crash happened. Also, again, the eventual investigation by NTSB didn't put much blame on the Uber car as much as it did on the human. So, from these two anecdotes, it's kind of curious to ask like whether there is something systematic about us wanting to blame the human when they share responsibility with the machine. So what we did is we did a set of a survey kind of studies, and instead of focusing on dilemmas, now we focused on cases of avoidable harm. So the car could actually now, or the person who's driving could actually avoid killing the person. So in this case, we have one of these two car models where it has two drivers, one in control, one on standby, and the car has, and then a pedestrian is jump in front of the car, and brake fails, but the main driver could actually swerve to avoid killing this one person. But then we say this main driver didn't stay on their track, and now the standby driver, it's their chance to intervene, but they also don't do anything, and as a result, the person dies. So in this case, both of them did a mistake, and the person dies, and then we ask people how they attribute blame. In one of the cases, we tried to make this as ecologically valid as possible. We framed it to make it look as if it was a news or a press release and make people read it, because we were interested in seeing how do people react or form their opinion as if they were reading about this crash in the news. So we used these two car models that I mentioned, and then we also used two fictitious car models. One of them that has two human drivers, a human in control and human on standby, and then one that has two machines, like two different softwares, one in control and one standby. What did we find? We found that in the guardian type, where we have humans driving most of the time and the machine could override, when they both do mistakes, people blame the human more, all right? In the other model, the Tesla-like model, where the machine is in control and driving most of the time and the human could override, something wrong happens, also people blame the human more. So no matter what the role of the human in the driving, people blame the human more in both cases. In addition, we also compared the blame to the machine in both cars to the blame of the machine when it's sharing responsibility with another machine. And we found that the blame to the machine just decreases as we pair it with a human as compared to pairing it with another machine. While for the human driver, the blame stays the same. Okay, so how much time do I still have? Do I still have like a 5 or 10 minutes? If so, I'll just talk about these other studies.
Sorry, you have 5 minutes, sorry.
Okay. All right, so as I said at the beginning, all of this was inspired by the Mono Machine project was inspired by the Trolley Problem, which is a philosophical conundrum. And in fact, the broad reach of the Mono Machine website basically encouraged us to put those dilemmas themselves, add them to the website. So we did this kind of version of it. But I'll talk about why this was, why is this important, what we did here. So many of you are familiar with the trolley problem. The original version, or the most common or popular version, is you have a trolley on the track. So here we're not talking about driverless cars anymore. You have a trolley on the track. It's headed to kill 5 workers. And you're standing next to a switch, or there is a man in blue here standing next to the switch, and this man could, pull the switch, and which will divert the trolley from its main track, avoiding killing those 5 workers. But that means it will kill this one worker on the side. Now, many people, let's say philosophers, have argued, or ethicists have argued, that in this case it is better to that this person in blue should pull the switch, and in order to sacrifice 1 to save 5. Okay. Also, when they asked people or the public, most people also approve of this decision. Let's take a slightly different version of this dilemma. Now, the trolley is also going to kill 5 workers, but you are standing on a bridge, on a footbridge on top of this road, and standing next to a large person who, if you push and they fall, the trolley is going to hit and kill, but then it will not kill the 5 workers. So the question is, would you push the large man, or would you not push the large man? Now, most philosophers and also most people in their asked, they said that you should not push the large man, and you should leave the trolley to go and kill the 5 people. And this is kind of interesting, because now if you compare this with the original version, in both cases you have 1 versus 5. Yet in one version, you think it's okay to sacrifice 1 to save 5. In the other one, you don't think so. So why is that the case? And there are actually two cases. There are two reasons why people hypothesized about. The first reason is that, well, in one case you're actually pulling a switch, so you don't have this kind of emotional kind of thing about that you have in the second case, where you're actually applying a personal force to push this one person. So there's something about the personal force that makes it more kind of emotionally unacceptable, which is not available in the case of the switch. The second difference is that arguably that the death of the one person in the switch is more like a side effect of you trying to save the 5 people. So if you think about this case, if you pull the switch, or if the man in blue pulled the switch, and that one person on the side runs away, you would be happy, right? Like, this is the best option that you could have get. While in the footbridge example, you need the trolley to kill the one person. Otherwise, if it doesn't, it's not going to stop. It's just going to continue to kill the 5 people. So in a way, killing the one, it's more like you are kind of like actively pushing this large person to kill them in the footbridge, while in the switch, you're merely, their death came as a side effect. And this is something called as doctrine of double effect. So we have a third dilemma, which kind of comes in between these two. It's called the loop. And in this dilemma, the trolley is also going to kill 5 people, and they have this man in blue who you could pull the switch and divert it from the main track where there is one worker. And the trolley, if you do that, the trolley is going to kill this one worker, which means it will not kill the 5 people. Now notice that this kind of it's kind of now starting to feel like very contrived, but this is also kind of a clever way. It's a kind of a clever middle scenario between these two, because similar to the switch, you are also talking about switch, but unlike the switch case, if the one person on the side runs away now, the trolley is going to loop back and kill the 5 people. So in a way, you do need the trolley to kill this one person. And there was some kind of argument over whether you have intention in this case or the man in blue have intention to kill this person, or they just happen to be merely running away. Anyway, we kind of all should agree at least that whether you should pull the switch in the loop should come in between the case of the switch and the footbridge, right? So there was a lot of research that was done in psychology about collecting questions, asking people about these cases, obviously. But most of this research was done in the US or in Western countries. Some research have done it with, let's say, people from China or Japan, but it was mostly like 1 or 2 countries that were involved. Some research that was done did like maybe with 10 or 12 countries as well, but the sample size was very small from the non-American countries. We used basically, because we put this on the More Machine website, we could leverage the popularity, and we had people coming from a lot of countries as well. For this analysis, we only included countries that we had at least 200 users from, which ended up with 42 countries. And interestingly, we found that this order of sacrifice of one person is the same in every country. So as I explained the logic before, that people are more likely to find it more acceptable to sacrifice the one person in switch, and then in loop, and then in footbridge. So this is like the yellow, white, and then red. And you see here like the same order is in every country. Now the magnitude is where there is a variation, and that's something that we also show that it could be predicted by some factor called relational mobility, but I'm not going to talk about here. I just want to say, almost done. We have a similar website that was inspired by the More Machines called My Goodness, which was also done in collaboration with the Life You Can Save Foundation, which is founded by Peter Singer, which is kind of a similar style. You have $100 that could save. You could give it to Charity A, which will save 20 women in Northern Africa by providing them nutritious meals. Or you could give it to Charity B, which will help 4 women in North America, providing them clean water. And people would also choose between these 2 scenarios. This was also done using some kind of different factors from the literature. I'm not going to talk about it. Lastly, we also have a survey that we put about COVID. It's not really pictorial. It's just more about asking about the ventilators problem. How should the ventilators should be allocated? as well. And if you're interested, you can go to the website More Machine. We changed the link now, but if you go to this link, you will still be directed to the new link where you could also see these questions. I'm done. Sorry for taking more time than I should.
No problem. Thank you very much. Thank you for the really provoking and an interesting talk. So let me remember for the attendees to ask question, you can simply raise the hand button in the Zoom. For people following in YouTube, you can write an email at iesociety.unipd@gmail.com, iesociety.unipd@gmail.com. So if you want to have, if you want to drop a question, I can read it. And instead, I will start for the discussion, giving the words to our panelists. So we have with us Andrea, Lamberto, and Elisa that are leading the project iSociety. So if you want to ask question to Edmond, you can just unmute yourself. So I can start with some let's say more technical questions. I start with two. Then the first question is something that actually I realized when I did myself the Model Machine game, okay, a while ago. Okay, so and I was thinking that maybe I'm missing the point that it might be crucial. That's why this is the question. I would like to have your feedback about it. Is that there is no a constraint in time for the decision, in the sense that all the time you need to do such a decision, you have very like half a second to do it, and instead during the game you can like look at the figures, you can think, you can reason. So the first question I want to ask you is what about the effect of time constraints in the human decision on this game?
Mm-hmm. Yeah, I think the question that we asked could have been asked in many different ways, and we had to stick to one of them. We could have also presented all these different ways of asking the questions. We could have made it timed as well, as you said, or not. I think in our case, we were more interested in knowing what people think in the comfort of an armchair, more than what they would have done as drivers, right? And I think many people argued that, well, you should ask people, we should put people in simulators. And many people have done this actually research where they put people in simulators and present them with these situations and see how they would have reacted. I think in this case, we're more interested in what people would say, not as driver. And if anything, we don't want to follow what the human driver would do in these situations. It's even probably could be even worse than what they would have said as if we're sitting and relaxed. Okay. But it's still, I think it's like both are interesting questions to ask.
Okay, thank you. Mm-hmm. So I just do the second question very quick. It's about when you do the hierarchical clustering. I was wondering, so you basically started with a previous classification, I mean a cultural classification, and then you look at the result based on this priori classification. I was wondering if you performed also some kind of unsupervised cluster algorithm where you didn't decide a priori the number of the groups, but somehow you let from the data emerging the different clusters, let's say, based on the response on some future maybe.
Yeah, so we didn't actually. So those classes that we use here were not really used in the clustering, right? Okay. We just used them after we produced the dendrogram. So the dendrogram here is just calculated based only on the answers in each countries.
Okay.
The coloring is done So the coloring that we choose, for example, when we split here, it's just like you, at some point you decide I'm going to do the split because it's like a tree, right? And you could decide to cut at any branch. So we just want to cut quite early to see what are the main broad things. And in this case, you would see that it's a southern, eastern, western. And then based on the classes that that these two scholars have put, we colored the country's name.
Okay.
We also did so this is visually useful for inspection, but we also did a statistical test as well to show that that this clustering is better than random. It's better than random in terms of these classes as well.
Okay, thank you. Now it's clear. Andrea?
Yes, I have a question. Thank you so much. It was very impressive. I've learned a lot. And it's going to take me time to process all the information you get. Thank you so much. So as a lawyer, I see that the problem of having a self-driving car as a twofold problem. On the one hand, I am addressing a car of driving me somewhere. So I'm very confident that the car is working and is taking me safely somewhere. On the other hand, there's a problem of taking the blame for what the car is doing, right? Which is a different problem, but when I take a car like this, I actually take some sort of responsibility for both, right? So do you think that the statistics suggest you can separate the fields, or that people, when considering buying a car or taking a car like this, will consider the ramifications of having a car potentially ramming into someone as one of the issues that people must be aware of? Or it's just a secondary thought that will just come out later?
You mean, so if I understand correctly, you're talking about the possibility that the car will have a crash or will make these kind of decisions?
Well, these are very difficult decisions, right? So these are moral questions lingering around. So I'm wondering whether these kind of questions really, if you think that these are questions affect the success of self-driving cars.
The success, you mean in terms of adoption?
Right, using them, selling them, right?
Yes, so I think, well, there are two levels on this, right? So there is the level of whether they will actually happen or not, right? And if the probability that they are happening is very, very small, but not zero, then it is important to think about these situations, because once they do happen, they might have a huge impact, right? But even if they don't happen, I think they're a starting point to think about the underlying or the subtle risk distribution that could be unfair. So I think that's, if we want to talk about something that is more realistic, let's say, that these questions will tell us about is, let's say those cars end up making a crash accident where the car, on aggregate, they are killing, most of the people who dies are kids. Then maybe people will be more outraged by this technology than if it was disproportionately killing elderly, right? Or if it was disproportionately killing cyclists, or right. So I think this is kind of this is how it had to. I think in each of these cases it might not be acceptable, right? Even if the car is making lower crashes in total, right? If 90% of those crashes are basically systematically disadvantaging some specific groups, then it is worth opening this discussion, right?
And excuse me, just this is another thought because of what you said. So normally these risks are outsourced through insurances, right? So you take an insurance and you are secure. So we are really talking about moral dilemmas that drivers or users of these cars can face because of this, right? So so I think that this is fascinating also for this reason, right?
Sorry, what?
I'm saying that normally, from a legal point of view, most of the issues we're talking about are issues that are handled by insurance companies, right? Because we normally have insurance companies, many countries have insurance companies taking care of this. But so in a nutshell, what we are really talking about is the moral responsibility that attaches to using these cars, which makes the topic very fascinating to me.
Right. And it's also, I mean, the fact that it's also handled by insurance doesn't mean that it's like, first of all, like the insurance, it seems like this could be, the insurance part could become part of the car price itself. And in this case, it could play a role in disproportionately increasing the price of the car if it's not clear how much the blame is going to be put on the person, right? Like if it's uncertain how much blame, the manufacturers might decide that this, or the insurance company might decide that this should be a high price, in which case this could inflate the car prices, which means lower adoption as well. So it's kind of related as well in that case, I guess.
Thank you.
So there is questions from the attendees. Paolo, can you do it yourself if you want?
Yes, of course I can.
Thanks.
Thank you, first of all, for your talk. I found it really interesting. And it's already kind of been answered, but I'd like to know more about legal liabilities.
Mm-hmm.
Because as you pointed out in the Guardian Tesla experiment, humans turn out to be blamed more. But I'm also like assuming that they want legally to be blamed and like to deal with insurance.
Yes,
and my second question is also related to the amount of the data set that I found it impressive. And I would like to know how you can gather so much data only just with a website. Do you like use promotion and how since it's like worldwide?
Yeah. So in terms of liability, to be honest, I'm not completely sure about how it is done currently or what's the current law on it. I just know that it is if these things are, for example, I talked to one person about one point about how it could influence the pricing of these cars, which is obviously something important because it's related to the adoption part. It could be also related to if these are done in a if the blame and liability is done in a tort law or something, then that could also be how people see it, how people distribute responsibility could be a very relevant question as well. So I'm not sure what's the current state is about these things. In terms of data, this is basically, we were kind of like when we designed this, think about this as just another way or another tool of collecting data, right? Like you could bring student in and make them do some kind of answer survey, or you could put your survey on Amazon Mechanical Turk and collect data. This is just another way of doing it. You could get a lot of people at the same time. The people that we had are obviously self-selected. It's just the group of people who are especially interested in driverless cars. When we designed this website, we tried to optimize for getting as many people as possible. So that was kind of reflected in the decisions we made by making it as, first of all, visually appealing as possible, as simple task it is, just choosing between two, providing the summary at the end to make it look like a personality test. But at the same time, even with all of these factors, you're not really guaranteed that you're going to get people coming to the website. I think an important thing is that the topic itself is interesting. People like to think about these things and talk about these things. So that was also another factor. We were also lucky. We had a lot of people coming to the website. So all of these kind of factors contributed to getting all of that. Like we had people on Reddit posting about it. So we went to the front page. Obviously, this brought us a lot of users, YouTubers who are, recording themselves playing it. These are all things that are obviously outside our control, and we were lucky that they happen, right? So I don't know if we can replicate this again. In fact, in the My Goodness website, we made it very similar to the More machine, but we didn't get as many people. Obviously, people are not interested in charity dilemmas as much as in driverless cars and the trolley problem.
Okay, thank you. There is another question from one of our from the YouTube viewers. So Noemi, she's want to know if you plan or already you have make this data available for philosophy research centers, and also if there have been any collaboration with car companies or something else.
Yeah, so the data, we made the data that was used in those figures available with the publication. I'm happy to send the link to it via email to you, and then you could forward it to them. For car companies, we've had a lot of talks with car companies. We've talked to many. I think many are interested in doing research about this, but there is no incentive for car companies to basically invest in this part of work. First of all, it's like they'll be blamed no matter what they do, right? I mean, one example is the case, the guy from the Mercedes who said, who tried to rationalize their answer and say the car should save their own passengers because they're very sure they can save the passenger, but they're not sure they can save the pedestrians, and they got like in a big there was like in trouble. I think there's no incentive for them to actually think about this or even like invest anything about it. But so that's why I think like it's an important thing that these things are basically influenced through policy and through regulations by providing a good incentive for companies to care about these things, where they don't have a disadvantaging one groups of citizens on the road. Right? Obviously, there is some kind of PR as well that could incentivize companies to care about these things. But so far, that's kind of my impression as well from talking to these companies.
Okay, thank you. So, if there are no other questions, so the last chance, if you have questions, raise your hands.
I have a question.
Okay.
If you don't mind, I'm exploiting you.
Please.
So, in terms of the marketability of self-driving cars, do you think there's an environment that is more likely to market these cars because of the social perception of the dangers that it might involve once these cars are used?
I'm not sure I understand the question.
I'm wondering whether, so you have seen a lot of different inclinations towards blame, who's going to take the blame, and who's going to be held responsible, should be held responsible, how people should react in case of danger, right? And what the cars should be doing. So I'm wondering whether all in all, there's a sort of cultural mindset that is more likely to accept these cars and the risks that come with them? Or
yeah, it's interesting. Honestly, I don't know. I mean, it seems like it could be that, if you ask now the experts, right, like the experts of automated vehicles, it seems like the biggest adoption of this technology could happen in China, in the Emirates, and Singapore. And it seems like in this kind of, especially these three countries who seemed like open for having this technology more implemented on a broader scale. And, it could be something about, people in those countries are more accepting of this technology, or just the governments in these countries are more open to these technologies being implemented for now. but how I think it's just gonna, the opinion's gonna shift depending on, obviously in the future. And the same way where people used to be scared of elevators when they were first put in place, and now just we don't think about it. I think once they kind of establish the reliability and the performance, maybe there's something also about how they are being communicated and framed that could play a role as well. It seems like so far, to be honest, and sadly, that car companies that are leading this development are more like coming from the computer science kind of field, just like the Silicon Valley kind of, it's like a Waymo and Tesla, which are kind of, which have the kind of more like a, move fast and break things kind of mentality over, over the extensive testing that is usually done by other car companies who are also in the race, like Toyota or even Mercedes, who actually dropped from the race very recently. So all of this kind of car company, you could see like the difference between the established car companies who are in this race, how they don't make any claim, they don't talk about how soon this will be, right? They're just working silently with a lot of testing, versus you see like Tesla every day, you hear news about these cars going to be next year or in 2 years. So it's kind of also like, it would be like kind of a really, could play a big role in how people accept them if they are put prematurely on the road and they start making mistakes before they're properly tested, right?
Okay, so thank you again, Edmond, for this very interesting discussion and presentation. I think you.
Elisa has a question. Sorry.
Sorry, I didn't see. Sorry.
Go yes, on. Thank you, Samir. Last question, and I hope to be brief. Thank you again for the very interesting presentation. So, my question is related to the one did by Andrea, the last one, and is composed of 2 blocks. The first one: there are anybody who uses your data for policy making? Because I saw that you explain us, you present us how the criteria of your investigation was used by the German ethics committees, German ethical committees. Mm-hmm. And I'd like to know if they then use this kind of data and the conclusion they achieved for policy making, because this kind of democratic definitions of the ethic criteria of technology is really interesting. And the second part of my question concerns the scope of your investigation, and I'd like to know if you consider to introduce even a question about the acceptability of this kind of automation, and and which degree of automation is socially acceptable. I don't know if I was clear, and I know that I ask a lot of things, but I like to have at least a feedback from you. Thank you.
Yeah, sure. First of all, I just want to clarify that we didn't say that the German committee used our data or anything. I was just saying that in Germany, they formed their committee, obviously independently in 2016, and the committee of experts came up with kind of set of guidelines. I was just comparing what we found people preferences are and comparing it with specific, like I was picking sentences from the commission's report to compare with it. I don't think there's any special country or like any special kind of regulations that is using our data. I think one of the co-authors on this work, Jean-François Bonfond, was headed a committee, European Committee for Automated Vehicles, and they had a report recently, and they mentioned these kind of moral dilemmas in the report as well. Not necessarily by using those data numerically, and I don't think any policy making should use any of this data numerically. or quantitatively. I think it's what makes this. I think any policymakers should have their own data collection, especially for their countries or for their own region or for any specific cases. They should design their own study and their own effort of data collection. I think what this provides is more like a starting point of discussion, and also provides this aspect of cross-country comparisons, which is usually hard to do. For it's like quite costly to do by yourself. So it's just like a starting point, not really to be used specially. And we're not really saying that any of these preferences should be used or should be considered. It's just saying, listen, this is what people think, and this is what people think in different countries. Maybe if you are, let's say, a policymaker in the Maldives or whatever, we could see how the Maldives are different from the rest of the world using what we see in our data. But if you have their own, if you want to put your own policies, you want to investigate more representative samples of people who live there to get a more accurate and more informed decision. The second question about, I forgot what it was. Yeah.
It was about the democratic process and
the social acceptability of automation and the degree of automation. If you consider, or if other studies, I don't know about your starting from your experience, if there are studies that focus even on the degree of social acceptability of automation, because I think that considering the possible applications that we may have of self-driving cars or other kinds of automation, probably the blame for the human action or inaction and the responsibility of the machine maybe would be changed considering different target of users or different condition. And so there could be even a democratic process to decide where this kind of automation can be used and where the risk involved in their using is socially acceptable due to other benefits.
Yeah, I don't think honestly that this should be put to vote just upfront like this. I think from a democratic point of view, I think this is like you have an elected representative who basically hire, let's say, committee of experts, or let's say they hire, an expert or a group of experts who basically could have the knowledge about the normative ethics aspect. But at the same time, when they need to break ties, or when they need to, let's say, there are some issues that they're not sure how the public feels about, and this is something that this is like part of the tools of the current democracies, right? Like any policymakers today, they have these tools that's called like a public opinion polling or public comments, where provide like a platform for the public to come and give their opinions about the different drafts of policies before they are being announced, right? And they say like, this is acceptable, not acceptable, regardless. But the policymaker eventually makes or publish the report. Sometimes regardless. Sometimes considering these things or not. Sometimes they might be convinced to change their opinion by it. But I don't think these things should be made as in voting, because you could think about it in many different ways. It could be that some companies are lobbying to get this technology on the road, and somehow they end up getting the votes by people, or like, let's say, influence people's decision in a way or another. On the other hand, this technology could actually reach a much better safety levels than the human drivers, and there might be some kind of a moral argument to have them on the road, but people are still afraid of them. So it could happen either way. I don't know if that explains what I thought.
Yes, thanks. I think you stimulate the fact that I mean, the aim of the study, in your review, was more to like be informative rather than substitute any kind of decision made at the political level. I think that this
Exactly.
is interesting also part of the discussion, how room to leave to political decision, how room to lead to maybe that each one can maybe, you know, program there is a room where every individual can program some kind of different safe, I mean, different features for their own car. I don't know. So I think, of course, the topic is really open and really interesting, and I really thank you for your contribution to this discussion. So thank you all for being present, and stay tuned. At the beginning of December, we will have 2 very interesting seminars, right, Andrea? If you want to say very quickly a word, and then you are mute, Andrea. Yeah.
Yes, thank you. So one will be about the utilization of AI to process language, legal language, which is an instrument that is being implemented around the world with great success, but also some controversies. And this will be on the 2nd of December. The other event will be on the 4th of December. We will have the deputy president of the privacy agency, which is the agency that takes care of data protection in Italy. The second one will be held in Italian, and just because of the topics and the
Specificity.
Yes, the narrative invites that language framework. So everybody's invited, of course.
Anyway, in the website, we will find all the information. And so thank you again, Edmond, and
Thank you for
hopefully
inviting
to
me.
see you in person very soon.
Yes, I hope that as well. And thank you for